and thank you for joining us for our very first Aitech virtual customer forum event. There's no doubt that we are all facing a new reality with COVID-19. And in this new reality, there are challenges such as AI in the future of battlefield and cyber threats that will accelerate in the post-COVID-19 era. That's why Aitech has decided to focus on these two topics today and challenges that we are all facing in our 2020 annual event. With that, let's go to the agenda slide that you can see here. And we will be covering a variety of topics today. The first one starting with Yaron Munn, who is the CEO of Aitech, and he's going to be focusing on the overview and challenges that we are all facing in the defense industry today. We will then continue with Pratish Shah, who is our second presenter. He is the Aitech US Division General Manager, and he will be focusing on the defense markets from AI to cybersecurity. Followed Pratish, we will have our next presenter, who is Emil Kafetz, who is the Aitech Director of Technical Business Development. He will be presenting the world standardization changes. Excuse me, sorry. He is focusing on the standardization changes of key game changers in the defense market. We then will continue with our next presenter, who is the Vice President Marketing, Vice President Duke Tran, and he will be covering the global aerospace trends that we are all facing. Then we will continue into two different sessions that will be focusing on both AI and cybersecurity as SWaP-C optimization. We have an exciting 90 minutes ahead of us, and that will also include an interactive live question and answer session at the end, where we will provide you answers with any questions you have with the session. In between both sessions, we will be inviting you to answer two poll questions that we provide. Our Aitech team greatly values your feedback, and as such, for those who will stay with us till the end of this session, we will be providing a customer satisfaction survey that we would greatly appreciate you fill out so that we can best provide you with the resources that you are looking for. As such, we will be doing a draw of a $100 Amazon gift card for those who fill out our customer satisfaction survey. Those who provide the survey feedback, we will be announcing the winner following the event. So let's get started with our first presenter, Yaron Munn, who is the Chief Executive Officer at Aitech.
Hello everyone and welcome for our virtual conference. I would like to thank you all for attending us today and spending the time with us, and hoping to meet with you in person when we will do our conference for next year. I would like to take the opportunity in the next few minutes to introduce myself a bit, to introduce Aitech. I know many of you know Aitech for many years, but the company has been changed quite heavily in the last few years. So we will try to update you all what has happened in Aitech, and also to share with you the way we see our sector, the defense sector, in these strange days of mid-COVID, post-COVID trends and situation. A bit about myself, a bit more than 45 years old. I live in Israel, in Kfar Saba. I have 3 kids and one that additional one coming almost every week now. I joined Aitech a bit more than a year and a half. I graduated both my bachelor and master degree in industrial engineering from the Technion in Israel. My first work after graduating almost 20 years ago was in the production electronics line for automatic testing equipment in the defense sector. But since then, I moved more to leadership and management position. I worked in various industries, not necessarily only in defense or electronics. Most of my position were in global companies in various size and countries. I believe my main expertise is transition management and growth enhancement within the companies. I would like to start by sharing with you our vision. For me, a vision for a company is something that is quite significant, and each and every word matters. I believe you can read for yourself, I would like to focus on the first and last words. The first word in our vision is creating. I believe this is our main value, and that's what we do. We create systems, we create solutions. We have IP, we have knowledge. We are not just delivering, assembly, providing, integrating, or whatever. So we are creating solutions, and all of our solutions are embedded in our customers, in yours application and solution. And together, I believe we are securing a safer and a better tomorrow for mankind. We operate today in 3 facilities, US, Israel, and India. We have a bit more than 200 employees. We have a global virtual organizational chart, so we have one global leadership team with team members in all of the 3 countries. Basically, in these days, the place where you live doesn't necessarily affect the way you can do your work. In all of our facilities, we are capable for engineering, production, customer service and support, production. So we are fully flexible to meet the needs and the demands for the various needs of our customers. In these slides, you can see an attempt to summarize everything we can do for you. So we have identified our products line. You can see them on the left side of the slide. I will not read them through, but you should know and be aware that for each product line, we have a product line manager. 2 of them you will meet later on today. We have a roadmap, we have a technology and also production roadmap, and also mix of customized and off-the-shelf solution to support various needs. All of our product lines have application in all dimensions views, from space to land, sea, and air. We have built ourselves to provide a complete solution for 360 degrees for our customers. So as I said before, in every line and for each product, we have an off-the-shelf solution. We have a subsystem and semi-customized solution. We provide all kinds of support, from component engineering to customer support, program management, obsolescence management, all the certification and documentation needed. So we are quite flexible, but we build ourselves to provide a full solution to our wide customer base. You can see here some relevant examples. I will share with you some customer data later on, so maybe we'll move through. We have defined core values for the company that we quite strictly implementing both inbound and outbound of the company. Our passion to win and our passion to help our customers win their challenges and win their business. Creativity, both in our technology and in the way we do business. Respect for each other, but also for the whole ecosystem and environment. And last but not least, a very strong level of accountability all across the board. Now I would like to take a few minutes to share with you the way we look at trends in our industry. So the way I see it, we are living in a time where there are 2 strong trends that are affecting most of our industry situation. The first one is a technological revolution of the military conflict and the military field. That trend has started a few years ago, but we see it grow stronger and stronger. And the second one, of course, is the effect of the economical and health aspects of the COVID-19 situation, and all sort of estimation about what will happen in the near future. So if you look at the anonymity of military conflict, what we can see is a very strong focus on equipment modernization and not necessarily new equipment. We see growing focus on unmanned solution, both for ground, air, and space. Cybersecurity become an issue because of the unmanned vehicles that are traveling around the battlefield. Stronger and more sophisticated AI application, biological threats, use of robotics and small robotics. We see space becomes more and more relevant also for defense application, and especially the LEO, the lower space orbit. And everything has to be smaller, lighter, and faster, and I think we can all understand why. If we look about the effect of the COVID situation on our economical, so first thing to say that at least until now, global spending in defense remains stable, so we haven't seen a big decrease. Also forecasts for 2021 seems the same, but we all have a very high level of uncertainty, so that might change. Even though the spending is stable, the competition level is increasing for various reasons. I think one of the main reasons is the defense side became more attractive because the commercial sides of aerospace, as we all know, has less spendings and fundings. So companies in the past tried to compete in both arenas are now putting all the focus on the defense side. We also see an increased use of open system architectures that also supports the level of competition that is increasing. Lack of cash make the focus on modernization of equipment even stronger. So more and more governments will invest in upgrading platform rather than introducing new platform to the market. Cash being spent on recover from the COVID might require new ways of fundings. So I think all of us will be forced to be more creative in the near future, and supply chains becoming an issue. So more and more companies, especially the main defense consumers, governments, are trying to localize as much as they can. Lockdowns and shutdowns and all that, creating a much stronger need for flexibility and agility within the supply chain. So supply chains for sure will be the first things that will be see significant in our industry in the very near future. I would like to summarize by saying that when we look at the challenges and the trends and the legacy of Aitech, we believe that we are fully ready to meet those challenges and also to support our customers to meet their challenges. We have decided to use some numbers and not words to demonstrate why. We are investing a lot of money in R&D, double-digit percentage of our revenues every year in the last 20 years. We have delivered more than 100,000 of boards. We are growing again double-digit for almost 20 years now. So we have a high level of confidence that together we can succeed in moving forwards, even though we have some low-term challenges. Thanks again for joining us. Hoping you will have an interesting and fruitful seminar, and hoping to see you in person very soon. Bye-bye.
Thank you, Yaron, for our first presentation and introduction into our virtual customer forum. Now we will be going into our second presenter, who is Pratish Shah, and he is the Aitech US General Manager, and he will be covering the US defense market from AI to cybersecurity.
Welcome, everyone. Good morning, good afternoon. Thank you for joining us this day today on Tuesday, and welcome the opportunity to share a little bit about Aitech and our presence in the US. As Yaron mentioned earlier, Aitech is truly a global company, but we'll talk a little bit about our success and our history in the US market. So Aitech's headquarters is here in Southern California in Chatsworth. We're a Delaware registered corporation, we're DDTC registered, and we produce and manufacture products locally, and we continue to expand on that. Through various field offices and support offices throughout the US, we support our customers and our partners throughout the country. We're also excited to share that we're opening a new R&D center in Houston, focused on space digital electronics for both defense and commercial markets. And we're also looking forward to increasing our presence in the Northeast with opening up another support and field office to support our partners there as well throughout the US. We're excited to have over 35 years of presence in the US that allows us the opportunity to have 35 years of COTS flight pedigree. And having pedigree provides us success and history and proof to everyone that we are able to deliver rugged solutions to various needs. We are certified by the appropriate bodies, as well as shared by your own. We have a pretty healthy offering of capabilities and solutions. Everything from VME to GPGPU, enclosures, and power supplies. So we are excited to provide COTS for both aerospace and defense markets to the US customers for many years. Let's talk a little bit about some of our experience. Aitech brings unique COTS solutions from space to sea. And through that entire domain, from outside the atmosphere to under the water, we provide 35 years of flight and space pedigree bringing COTS hardware and systems from space all the way to underwater to our US customers. And let me provide some examples of some of the environments we're in, just to show that it's not just talk, but actually we are in missions out there covering all these domains. Space for us is a market, a location we've been in for over 30 years. We introduced COTS to space nearly 3 decades ago, and since then have had the opportunity to support everything from low Earth orbit all the way up to deep space exploration. We're excited to be a leading provider of COTS solutions to space. And as well, for those of you interested, we are holding a seminar tomorrow specifically about our space COTS offering. Between space and going into the atmosphere, very high altitude is a unique and a very challenging environment for ruggedized solutions. And whether it's supporting hypersonic missiles, or high altitude balloons or unique research platforms, we're excited to be able to provide ruggedized systems in this very challenging area. One example of this is we're providing GPU solutions that launch into low Earth orbit and then descend into the atmosphere to do data capture. A unique challenge that covers both space, re-entry, and the air domain. And we're excited to be partners in providing these technical solutions for these ruggedized environments. Going down a little bit into the air domain, we are as well very well versed and have been successful in providing everything from COTS hardware, boards, systems, computers that cover everything from rotary platforms, as well as unmanned platforms and weapon system, etc. So whether it's providing mission computers for rotary platforms or single board computer upgrades for unmanned solutions, we're excited to be part of the U.S. military, supporting the safety and security of U.S. personnel through technologies and ruggedized systems for the air domain. The ground domain provides another set of challenges. By no means are the challenges in the ground domain any easier or any harder. They provide different set of challenges. And similarly, through our history here in the US, we're excited to provide computers for fire control, to enclosures for mobile gun systems, as well as interface units, for vehicles or Stryker, etc. So again, just like the other domain areas, we're able to provide and have a rich pedigree and history in delivering COTS solutions for military in the ground domain. The sea and on-water area provides some unique challenges. Of course, the ruggedization requirement for on-water platforms is a little bit different than ground, a little bit different than air, and so forth. But again, similarly to the other domains, we're excited to have COTS offerings as well as proof in providing COTS solutions that cover everything from alarm control or alarm monitoring systems for the LCAC, or as well as subsystems for the antenna controllers, or SBCs for the Navy's multi-band terminal. So we're excited to provide on-water solutions to support our forces in the Navy and the Marines and so forth. And then lastly, we don't want to forget the fact that we do have platforms that go underwater, primarily in the submarine platforms. And similarly, we provide electronics that control everything from periscopes, control electronics, to as well as controller for oxygen and hydrogen generation systems for underwater platforms. So we're in a unique position. We have been in the US for over 30 years. And in that 30-year time frame, we've been honored and excited to provide support to our US military through our customers and through our prime partners, in delivering COTS hardware and systems that have flown from space to air, been on the ground, on water, and underwater as well. And as Yaron mentioned, we look forward to working with each of you to support a exciting future that supports a better tomorrow. So I will turn it back to you, Renee, and thank you for your time.
Thank you, Pratish. I would like to invite our third presenter, who is Emil Kafetz. the Technical Business Development Director at Aitech US. He will be discussing a presentation on the world standardization changes as key game changers in our defense market.
Thank you for introduction, Rene. Good morning and good afternoon. Today I'm going to talk about open standards such as SOSA and FACE and the impact on military programs, customers, and suppliers, including Aitech. Next. It's always a challenge to bring the latest technologies to military programs. On average, it takes about 10 years to bring new electronics equipment to a warfighter from concept to full rate production. In the commercial world, it takes 1 to 2 years or less for the new designs to reach consumers. For example, new generation cell phones are coming to the market every 6 to 9 months. Besides a long development cycle, new and upgrade military programs are very expensive. In order to address these issues, US Army, Navy, and Air Force in January 2019 formalized memorandum declaring modular open system approaches for a weapon system is a warfighting imperative. In this memo, the 3 branches of DoD committed to a common open standard approach to developing weapon systems to facilitate more rapid and economical development of technologies. The idea is to reduce development programs time by half, about 5 years on average, and to reduce development and upgrade program costs. Going forward, DoD is planning to include MOSA supporting standards in the majority of the new program requirements. Next, please. The Open Group has several common hardware standards initiatives. Sensor Open System Architecture, or SOSA consortium, is giving military and defense organizations a leg up in system development and communication, while building a solid ecosystem for all parties involved to work in unison. SOSA covers all aspects of sensor systems, from enclosures with different external connector pinout to plug-in modules and associated backplane interfaces and software modules. SOSA infrastructure covers hardware elements, plug-in cards, chassis, including connectors, mounting features, chassis manager, and power supplies. Runtime environment, which includes software operating system, virtual machines, and containers, and inter-module interaction infrastructure. Next. The complement to SOSA is a future airborne capability environment consortium, FACE, an open software environment that promotes application interoperability, portability with enhanced requirements for exchanging data among FACE components and emphasis on defining common language requirements. Systems and modules which are aligned with SOSA and conformant with FACE requirements can be used as building blocks for future military programs with generated commonality and interoperability between products from different vendors. This slide shows open standards relationships. Open system architecture under MOSA technical working group includes such open standards as SOSA and FACE. Full release standards conformance is verified under applicable standard guidelines requirements. SOSA plugin profiles are a subset of VITA 65.1 OpenVPX slot profiles. Only few slot profiles from VITA 65.1 was selected to minimize number of profiles options SOSA systems will need to support. SOSA system management is based on VITA 46.11 standard and hardware open system technology host 4.0 requirements. Utilization of existing open standards simplified efforts of SOSA standard development and leverage existing hardware and software solutions available on the market. Next, please. Speaking of SOSA and FACE standard status, SOSA standard is almost ready for the prime time. It is scheduled to be completed by December 31st, 2020. All working groups, committees are working around the clock processing changes and updates. Standard is planned to be formally released by summer 2021. Latest standard available is a snapshot 3. Until SOSA standard is released, vendors can only claim alignment with the standard instead of conformance. Phase technical standard is released. The latest version of the standards is 3.1. Standard is released and conformance verification tools and services are available. Next, please. The SOSA consortium truly facilitates technology reuse and enables the expansion of credible modular open system approach MOSA ecosystem. So why SOSA? SOSA relies heavily on established OpenVPX standard, which is widely used throughout military systems. Aitech was actively involved in the OpenVPX standard creation in VIT organization. SOSA is unique in deep level of involvement from DoD organization down to the system boards and connector manufacturers. More than 100 companies and organizations are members of SOSA consortium. Also, opportunity to participate in the standard development is exciting for both Aitech and our customers. By the time the standard is released, Aitech will bring to the market several plug-in modules products available for use in the upcoming defense programs. Next, please. The SOSA standard will help to reduce or eliminate a number of challenges that puzzle designers of military embedded systems for a long time. It will significantly reduce the development and product qualification time. It will be hard to match commercial products development timeline, but 50% improvement of current military programs timeline is expected. It will reduce cost of the development and maintenance. It will be easier to find a replacement product to address parts obsolescence issues. It will minimize integration and interoperability issues. If all products are tested for conformance to the applicable open standards, they will be able to interact with other conformant products in the system. It will also improve system sustainability and scalability. SOSA systems can be upgraded without any needs for redesign and to add replacement of high performance conformant plug-in modules. It will also improve and standardize communication protocols between different systems and between plug-in modules in the same system. And it will provide technology insertions capabilities without the need for complex redesign and requalification. Next, please. Aitech brings to SOSA technical standard its substantial rugged system and board reliable software design experience. Aitech, since its inception in 1983, was using open standards such as VME, Compact PCI, and later VPX for Milero systems and card level products. Joining SOSA consortium was a natural progression for Aitech in its quest to support rugged solutions market. Key SOSA areas of focus for Aitech include the following technical working groups. It's hardware subcommittee, intermodule interaction subcommittee, security subcommittee, and small form factor subcommittee. Next. Aitech is actively working on several SOSA line plug-in modules. Development work is focused on the following products. IO-intensive single board computers, SBCs, payload plug-in cards with GPGPU capabilities, data control plane Ethernet switches, and power supplies. First SOSA Line 3 UIO extensive SBC with enhanced cybersecurity features will be available in Q1 2021. Next, please. Aitech will offer hardware and software bundled solutions for even greater efficiencies in interoperability through combined efforts of the SOSA and FACE initiatives. A wide variety of SOSA line plugin modules from Aitech will simplify system integration support for our customers. If you're looking for SOSA line plugin modules or power supplies, please check with Aitech. Thank you, and back to you, Renee.
And we will invite our next speaker, who is Duke Tran, the Vice President of Global Marketing for Aitech, located in the USA. He will be discussing the global aerospace trends and how Aitech's technologies and solutions can best provide for the future of the aerospace industry.
Thank you, Renee, and good morning, good afternoon, everyone. And thank you for joining us today for our Aitech Virtual Customer Forum. I'm going to spend the next few minutes talking about a couple of future trends. We look at 3 different types of trends and to try to understand What are the implications of these trends into our industry, the ruggedized computing industry? The first of such trends, which you've just heard earlier, is the post-COVID-19 trend. It's worth having a look again, is that in the post-COVID environment where the government have to make more difficult decisions because of the fallout, the economic impact of COVID-19, these are some of the trends that we see. The modernizations of equipment, acceleration of digital technology, militarization of space, something that we see accelerating, unmanned solutions. We've also see that the open standard are widely used, starting to be widely used, such as SOSA and FACE. And one of the things that COVID exposed was the supply chain was disrupted. And this is true as well in the military and aerospace environments. And so localization and supply chain flexibility is becoming more common. So this is the first of such trends. The second type of trends we look at to see how it impacts our industry is looking at the Army of the future. We review what the DoD have said, what the Army of the future look like, and we summarize here for you guys in 4 major categories. The first of such is rapid, effective decision making. And this is the idea that the future battle space is very complex, and the speed of the decision making is too fast and too complex for human beings to be able to do. And so it relies a lot on artificial intelligence and predictive analytics. Without artificial intelligence and predictive analytics, this will not be possible. So this is something that we know is very important. The second of such trend is resilient information sharing. What this means is that the information need to be able to withstand any kinds of attack and needs to be distributed globally so that high quality information is available to everyone. To be able to achieve that, it requires a coordination between high performance computing electronics, high good connectivity, and robust satellite-based systems. The third trend that is important is it's called global persistent awareness. Is the idea that you have the information everywhere, wherever you are. And it's to have information superiority. And this rely on by having a lot of low-cost sensor integrated with platform that is redundant, so that the information is available in real time everywhere that is required. And the fourth trend here that we see that's impacting us is what's called complexity, unpredictability, and mass. The idea is to overwhelm the adversary with sheer number of items, be very unpredictable, and it's highly complex, so it's harder to be attacked. And this is done by leveraging artificial intelligence, low-cost sensor, networking, computing, communications, and a lot of systems. So it's about having numbers of systems, not just the small numbers of high value system that they currently have. So these are the 4 major trends in the Army of the Futures that will impact our industry. The third trend that we look at is space, how space is going to be in the next 10 years. What you can see in the chart here is that we are going through a space boom. By 2025, you're looking at having roughly 1,000 satellite launch per year, which is about tripling of what it is today. And it's driven by a couple factors. One is the militarization of space, which we've mentioned already. The second thing is the increasing need for connectivity and data sharing, as information is becoming more and more important and rely on strong satellite connection to be able to deploy information globally. That combined with rapid deployment of space electronics and the fact that space electronic has lower in cost quite significantly in the last couple of decades. And one of the big driver for the lowering cost of electronic in space, it's what's called COTS-based space electronics, commercial off-the-shelf electronics, like the one produced by Aitech. And this is a very significant way to reduce the cost of accessibility for space. Let me say a word about the cost in space. So the reason why cost in space is such an important factor is that it's much more affordable. We are looking at up to 90% cheaper than full custom systems. It's also lower risk. Not only it's affordable, it's a lower risk systems. It's also more reliable. And for example, at Aitech, we're pioneer in COTS in space, and over 30 odd years or so, this product that we build has flown trillions of miles without a single failure, and so it's very reliable. And also the final thing about COTS in space is the systems is deployed much faster than what it would be a full customs. We're talking a matter of months as opposed to years. So again, it's a significant factor. And this is a significant way to reduce the cost of into space. Okay. So what does this all mean? Take it all together between the COVID world, between the Army of the Future, and the space trends, the militarization of space, and is that we can clearly see there's a greater need for computer power. I think this seems like an obvious one, but it's worth mentioning that the need for computing power is increasing exponentially. Same thing with acceleration of artificial intelligence. This is something it's absolutely required. We reach a point where not having it is no longer acceptable. The rise of parallel computing, things such as the GPU, which we'll talk about a bit later on. The protection against cyber threats. When you have more systems, you're more susceptible to cyber threats. With all these unmanned systems out there, and SWaP-C optimization was always there, but it's accelerated. Size, weight, power, and cost. This has always been important and continue to do so. SOSA and phase, which you've just heard. Localizations of production. This is to control the supply chain. And finally, COTS in space. Okay, now thank you very much. And back to you, Renee.
We welcome you to stay for our upcoming experts panel. So if you have any questions, our experts will be answering those. If you want to either put those in the chat or wait for the Q&A session, please do. At this stage, we have 2 sessions in a row, the first one being AI, which will be covered by Dan Moore, the Aitech GPGU product line manager. And then the second one is talking about deep learning in a nutshell and AI post-COVID-19. Use cases and new solutions. Our second session is cybersecurity and SWaP-C optimization, which will be discussed by Boris Bayer, our Aitech Vice President of Research and Development. And he will be discussing the cybersecurity development from deployment in our new reality. And our final presenter is Alex Trigub, who is the Aitech single board computer product line manager, who will be focusing on the more for less SWaP-C optimization post-COVID-19 era. This will be followed by our experts panel, and we will be answering all of your questions then.
Hi, my name is Dan Moore. I'm a product line manager for GPU and graphics at Aitech company. The first talk will be deep learning in a nutshell. Let's see agenda. Deep learning in a nutshell. How GPU works, CUDA fundamentals, deep learning in a nutshell. We will start with how GPU works. In the middle, you can see a typical computer, the central processor unit and a memory. From the left, you can see an input. Input can be keyboard, mouse, or any kind of peripheral device. Output can be connected to external monitor. How a CPU works. The central processor unit is a collection of million transistors. Basically, is CPU best for the serial processing. Modern CPU can parallel process for some activities, but they are not originally designed for. How a GPU works. GPU from the beginning was designed for parallel processing, performing many tasks in parallel. In this example, you can see how each pixel in the image frame handled by GPU in parallel. For each pixel in image, we want to calculate pixel color and its coordinates. All this should be done in parallel in order to render image as fast as possible. Now imagine you want to move 3D image in space. How many calculations for each pixel in image should be done? Imagine we need to do it in serial instead of parallel. CPUs and GPUs. CPU and GPU working always in parallel. However, GPU features massive parallelism and designed for more specific computations. CPU have large instruction set, which allow them to perform a wider range of tasks. A system will typically have at least one CPU and one GPU, and they will always work in parallel. Let's see an example of pizza delivery. We can try to demonstrate a CPU sequential computation as an example of pizza delivery. Delivering a pizza in this case will be done one pizza at the time, from one house to the last in the chain. Now let's see how pizza will be delivered by GPU. Imagine you have in each delivery point and delivery person. When ready, all the team will start delivering process and will be done in parallel and not one at a time. GPU is actually perfect for AI, deep learning, and big data analysis because AI used so-called neural network, which takes multiple inputs, has multiple hidden layers, neurons, and nodes, and then provide outputs. What NVIDIA found is that the parallel processing on GPU is perfect for these neurons on hidden layers on multiple inputs. So GPU can run AI faster than CPU and trading them in parallel. AI and deep learning is sweeping across industries. We can see the AI in internet service industry, in medicine, media and entertainment industry, security and defense, autonomous machines. Let's talk about CUDA fundamentals. Accelerating computing growing rapidly thanks to CUDA features offered by NVIDIA. Just for the last 6 years, we can see tremendous growing of CUDA developers. As an example, for today, all top HPC applications are GPU accelerated. CUDA now is powered today most fastest supercomputers. All the popular deep learning frameworks like Caffe, TensorFlow, PyTorch accelerated by GPU, as well as any professional applications which need heavy computation. For example, mechanical engineering using AutoCAD, which accelerated by CUDA. CUDA is available everywhere, in the cloud, in the system, on a PC, desktop station, or laptops. Let's see an example of how parallel programmers work. We need to put parallel parts of code, which is usually consumed on the runtime to the parallel hardware, and keep the rest of the code on CPU, like file I/O, network, communication. CUDA make it easy to switch between the targets. This means we would like to identify which code is running most of the time and how we can make it work in parallel. Then we can move this code to GPU. It's called offloading, and free CPU to other I/O tasks, or so-called mission-critical applications. We can see 3 layers here: a language support layer, development environment layer, and programming approach. CUDA Toolkit includes all the components you need to build your application for parallel programming. The toolkit includes GPU-accelerated libraries, compile tool chains, rich debugging and profiling tools to help developers build applications optimized for GPU. CUDA includes optimized library for a variety of applications, for linear algebra, for parallel algorithms, for deep learning, for signal and image video processing. Let's see example of 3 steps of CUDA accelerated application. Step 1. We can substitute library call like saxpy to the cuBLAS saxpy. Step 2. Need to use CUDA calls from memory allocations, or we're a way to automate it with the CUDA memory manager. Step 3. Link with CUDA accelerated library while compiling. In this example, you can see we're compiling an image and link it with the cuBLAS accelerated CUDA library. Let's see example, some CUDA C. CUDA C was the first language supported on the CUDA platform. Example of saxpy function. saxpy stands for scalar and time x plus y. It's linear algebra function, which scales each element of vector x and end result to corresponding element of vector y. you can see a for loop which is executed serially. From the right, CUDA implementation. Same arguments and computation looks the same. The difference is that instead of sequential looping of n elements, CUDA launches n threads, and each thread is responsible for each element of the computation. 3 brackets specifying how much threads we want to launch. The first value is a group of threads, blocks, and the second value is a number of threads in the given block. In this example, we launch 4096 blocks of 256 threads. It's about 1 million threads in all. Additional approach with simplify CUDA programming is using OpenACC tool. We can comment GPU target software code with pragmas, and this code will be optimized for GPU usage. The next slide is deep learning in a nutshell. Let's start with the business question. You have several inputs. One of the input can be text, image, video, or audio. The business question you can ask in case of text input data: is it present or not? If it's present, the AI task will be detection. If it's an image input, what type of thing is it? In this case, AI task will be classification. In case of video, what extent it's present? In this case, it will be segmentation. For the video, what is the likely outcome? In this case, it will be prediction. And the last one is the audio input. What will likely satisfy the objectives? In this case, it will be recommendation. From the right, you can see the pictures of classification image, classification and localization, object detection, and instance segmentation. Classification and image. It takes an image as an input and outputs the classification label of that image with some metrics: probability, loss, accuracy. For example, an image of a cat can be classified as a class label cat, or an image of a dog can be classified as a class label dog, with some probability. Detection. Object detection algorithms acts as a combination of image classification and object localization. The last one is a segmentation. Image segmentation is the further extension of object detection, in which we mark the presence of the object through pixel-wise mask generated for each object in the image. The good example in our market, it's a defense market, it's surveillance and security, face recognition, object tracking, actively recognition, and so on. This will be very intense, so please stay with me, guys. Let's take a look on how deep learning works in practice. Let's say we want to automatically identify a variety of different animals, which is classification task. The first step is to assemble a collection of representative examples to be used as a training dataset, which will serve the experience from which deep learning network will learn. If you need only to classify dogs and cats, you will need cat images and dog images in your dataset. In this example, you will need several thousand images, which are labeled if it is a cat image or dog image. The first step, we will take untrained model. The next, you will need a deep neural network model. Typically, it will be untrained deep learning network model designed to perform general tasks like detection, classification, or segmentation on a specific type of input data like images, text, audio, or video. Here you can see a very simple model of untrained neural network. On top of this model, there is a layer that has 4 input nodes, and at the bottom there is a layer of 2 output nodes. Between the input and output layers, there are a few so-called hidden layers with the several nodes each. White lines show which layers share this result, with nodes in the first hidden layer and so on, all the way down to the output layers. You may hear that the nodes refer to us as artificial neurons or perceptrons, since their simple behavior inspired by neurons in the human brain. A real deep neural network model will have many hidden layers between the input and output layer. This is why it's called deep, but the simplified representation here is fine for this example. Keep in mind that the design of deep neural network is what makes it suitable for particular task. For example, the best models for classification are very different from the best model for speech recognition. The differences can include the number of layers, number of nodes in each layer, the algorithm performed on each node, and the connection between the nodes. Many general models are already available for classification, object recognition, image segmentation, and several other tasks, but it's often necessary to modify these models to achieve high level of accuracy for the particular dataset. So computation is required to train one version of the model, multiplied by number of models that need to be evaluated. All this processing required tremendous computation power, much of which can be performed on cloud, which can be performed in parallel, which makes it ideal to accelerate it by GPUs. Let's see second step, training. Once you choose a generic model and you have a dataset, you can use deep learning framework like Caffe2, TensorFlow. These frameworks used to feed your dataset through the neural network. For each image that is processed through the neural network, each node and output layer indicates how confident is the image is a dog or a cat. In this case, it's only two options. So we have two nodes on the output layer, one for dogs and one for cats. When the final output is sorted from most confident to the least confident, the result is called confidence vector. The deep learning network then looks on the data labels and check if it gets correct answer. If it guesses correctly, the network strengthens the connection, which contribute to correct answers, and vice versa. The network reduces the weights that contribute to wrong answer. After processing entire dataset once, neural network will generally have enough experience for the correct answer, a little more than half of the time. It will require additional several rounds of processing of entire dataset to achieve high level of accuracy. There are many different neural networks to choose from. Each have their strength, programming languages, but they all GPU accelerated using CUDA, a deep neural network library, cuDNN, and other libraries from NVIDIA Deep Learning SDK. The third step, adding new capability. So now the model is trained with the large dataset. It can distinguish between cats and dogs, but if you will show a picture of raccoon, the model will be confused, and it doesn't have previous experience with raccoons, and we will probably get a low confidence vector for both dogs and cats. If you need to add raccoons to identification process, you need to modify design of the model and add a node to the output layer. Add a dataset which includes 1,000 of dataset, which represents raccoon, and use deep learning framework to retrain the model. There is no need to write additional raccoon instructor, just modify network topology of it and retrain the model with the new dataset. The fourth and the last step, inference. Once the model has been trained, now it's time to optimize it for significantly faster runtime performance. Common optimization include fusing layers in order to reduce memory and communication overhead, remove nodes that do not contribute significantly to results, and other techniques supported by NVIDIA TensorRT. Now we have fully trained and optimized model that is ready to be integrated in the application and feed it with images of cats and dogs, which is never seen by this model before. It will be able to quickly and accurately give correct answer based on its training. And the application can be displayed on GPU-accelerated platform, in the cloud, on a local workstation, on a robot, UAVs, and so on. Let's summarize what we learned today. We talked about how GPU works, we talked about CUDA fundamentals, and we talked about deep learning in a nutshell. The second talk will be AI GPU, post-COVID-19 trends and solutions. Let's see our agenda. Post-COVID-19 defense market needs, new exciting products, what it's cooking. Frost & Sullivan is a well-known market research company which provides reports for market status and trends. If we will look on the COVID-19 impact on the world GDP growth, we can see a recession expected during 2020. And as always, after recession, there is a spike during 2021. How we can make an advantage for this recession? We can use this recession time for IRAD planning and new product development. So when spike will come, and it always comes, we'll be ready with the new product for the new post-COVID-19 market. Which interesting market fields are identified by market research in post-COVID-19 world? Augmented reality, UAVs, which is unmanned vehicles, smart soldiers, and man-portable wearable devices. Let's look on airborne applications. Some of airborne applications required number of displays. Some of them displays and camera resolutions. What will be the next growth area? The total number of pixels and displays continuously growing. The resolution of images continuously growing too. Increasing in industry rapidly. Manned ground vehicles, cars, and aircrafts. Identifying market needs, image processing, object detection, tracking, classification, threat assessment. Objects are often partially obscured, occurred from visual imaging. Environmental factors and imaging artifacts like fog, rain, adverse lighting, disturbing our images. Enemy combinations of pedestrians can often fail to auto-identify and classify correctly. How we worked around 7 years ago? We used heavily CPUs. We need constantly add new features and algorithms. Image processing become more complex, high-resolution cameras and high video throughputs. All this caused to CPU core starvation, which leads to increased power consumption, which leads to complex cooling solutions and CPU throttling. The question is, do we need to compromise? Let's see and compare two architectures of CPU and GPU. The CPU is task-oriented processor with serial processing and sophisticated complex core. The GPU processes multiple image data simultaneously, can leverage parallel processing, have a simple cores, but many of them, actually thousands of cores. So what we are looking for? After seeing market demands, we can clearly see that the market required small form factor systems, which is swap optimized. Swap is the size, weight, and power, parallel computing, and variety of I/O. Aitech started its journey 7 years ago with the NVIDIA Jetson-based family. It was the first company which has introduced rugged NVIDIA-based device, which is small form factor. With the time, we become a preferred NVIDIA partner for the embedded market. AI and GPGPU systems. Let's present a product line for the GPGPU. From the right, you can see high-performance embedded computers. You can see the A191, A196, and A195. This system based on 3 UVPX form factor. All this system, including Intel-based SBC and NVIDIA-based GPGPU board. The GPGPU board is based on latest and greatest NVIDIA Turing technology GPUs. In the middle, you can see a small form factor product line. This product line based on NVIDIA Jetson family. The A178 based on NVIDIA AGX Xavier. The A176 is very small form factor system based on NVIDIA TX2 and TX2i. And we will talk about the new one, the nano form factor system, A179. This one will be really greatest product. AI and GPGPU boards. We also developing a 3U GPGPU board based on NVIDIA architecture. The latest C530 supported NVIDIA Quadro architecture, T1000 and RTX 3000 GPUs. We have also XMC and PMC AMD-based GPU boards. These boards perfect for real-time operating systems like VxWorks and Integrity. We are working on the new generation board, M599, which is based on the latest AMD E9171. The next line is the frame grabbers. The first one is XMC frame grabber with 8 simultaneously composite inputs, which is low power. The second one is XMC digital and analog frame grabber, which takes analog outputs and inputs with the low power consumption. A193 GPGPU system. This system actually based on the Intel-based SBC with the latest Xeon D and Xeon E processors, and C530 based on the latest Turing NVIDIA architecture and Quadro T1000 GPU. As we know, every GPGPU system based on Intel platform always based on SBC and GPGPU. The system coming with the cold plate cooled solution and convection cooled. We're also providing developer kits for the software development, which include cable breakout and the power supply. This is high-level block diagram of A193 system. You can see in the middle SBC with mounted frame grabbers 577 or 571, onboard SSD. You can see C530, which connected through the PCI Express, and you can see the power supply and 2.5-inch internal SSD storage. The next product is A178 Thunder. It's rugged GPGPU fanless AI supercomputer. This supercomputer is actually based on the latest NVIDIA AGX system on module. This is a very interesting product. Has NVMe SSD with quick arrays and secure arrays, removable SD storage. This product is environmentally sealed. Let's take a look on this product in close-up. This is A178 product. See how small is it? You can see the circular connector on the front panel. You can see 4 SMA connectors. These connectors for the high-speed HDSDI inputs. The system is very small, environmentally sealed, and stands for the MIL standard 810. One of the interesting interfaces for this system is the high-speed interfaces. This system has 10 gigabit Ethernet interface, USB 3, and 2 additional display ports. So, on this system, you have 3 independent video outputs. This is amazing. Let's take a close look on A178 block diagram. You can see this A178 based on NVIDIA Jetson Xavier AGX module. A lot of I/O available: gigabit Ethernet port, USB, HDMI, UART, discrete CAN bus, serial ports, and amazing high-speed interfaces: USB 3, 2 display ports, composite inputs, NVMe SSD, and 10 gigabit Ethernet. A176 Cyclone. This is the next small form factor GPGPU systems. This one is based on NVIDIA TX2 and TX2 industrial module. We have a SATA SSD, a lot of memory storage, video capture device, HD SDI input, H.264 hardware encoder, a lot of composite inputs, variety of I/O, gigabit Ethernet, UART, USB, discretes, composite inputs, SDI, and CAN bus. Let's take a close look to the A176 system. Let's take a look and compare 2 systems. One is A178 and the second one A176. Can you see the difference? Very small one. This small one, but it's very powerful. It's entirely rugged, environmentally sealed, with variety of I/O. This one is much more powerful, but this one is really swap size, weight, and power optimized. Let's take a close look on A176 block diagram. You can see Jetson TX2 and TX2i system on module, variety of I/O interfaces, gigabit Ethernet, USB, UART, discrete ports, CAN bus, and DVIs, and 2 expansion modules. These expansion modules, we can use them for the 8 simultaneously composite inputs and 1 HDSDI input. Let's cover the markets for this amazing product. This product can be used for the UAVs, for the signal processing, for autonomous robotics, intelligent video analytics, image capture in aerospace industry, persistent video surveillance, UGVs. I can't tell you about many projects we did for the aerospace and defense industry, since it's restricted, but I picked 2 projects actually which are very interesting and I'm very proud of. One of them we did for Boeing. It's A176 system. This system for unmanned electric air cargo air vehicle. Drone would eventually be able to deliver up to 227 kg of cargo within 15 or 30 km radius. Let's see a short movie.
When I saw it take off, I was inspired by it. This team of Boeing engineers was able to do the impossible and deliver a prototype.
In a matter of 3 months, we took a concept from a piece of paper all the way to a flying vehicle.
So this is an octocopter. It's fully electric on some Boeing custom designed batteries. The goal is to grow into a large-scale cargo platform. So if you extend the range and you extend the payload a little bit, when you think about delivering 250 to 500 pounds over a 10 or 20 mile radius, you can change the way that the world connects. You can change the way that we deliver goods.
You've really got a convergence of technologies right now in terms of hybrid electric propulsion, vertical takeoff and landing, and autonomy that is going to unlock air travel in areas that we haven't seen it before.
So it becomes a test bed for future businesses such as maybe electrically vertical takeoff cargo. This is my dream job of trying to come up with something new that the industry doesn't have yet. So it's exciting.
The company really is trying to change the future of the world. They are driving and on the leading edge and pushing the envelope, but doing it in a smart way.
Boeing is at the cutting edge of technology in aerospace. We have a chance here to really change air travel, and we'll look back on this day as a first step in that journey.
The next project we will present is based on A176. We did it for NASA. This is the first project we've done for space. Low Earth orbit flight test on inflatable decelerator, lofted, delivery of heavy payloads, experiment equipment, and people to destination with atmosphere. Lofted acts as a giant brake by deploying a large inflatable aeroshell and deployable aeroshell protected by flexible heat shield before entering the atmosphere. Which application we targeting with A176, A178, and actually all other small form factor GPGPU systems. GPGPU rendering, navigation and maps, CUDA-based algorithms, image processing, which are CUDA accelerated, radars, flight simulators, video recorders and streamers, surveillance, autonomous vehicles and drones, smart cities, GPGPU extensions to existing systems. Let's talk about what is cooking right now at the Aitech R&D department. A179, it's a new nano form factor GPGPU. It's actually AI supercomputer. It has a nano form factor, about 17 watt max, based on NVIDIA NX or latest Nano. Weight is less than 500 grams. Look on the size, it's very small, it's 10 by 5 centimeter. We are providing software and hardware add-ons for this system. Which market we are targeting? Smart soldiers, wearable devices, avionics, naval, ground mobiles, UAV, and of course industrial market can benefit from this product too. Smart agriculture, drones and surveillance. Let's take a look on the form factor of this system. This will be actually very interesting. Remember these two? So this one, A178, based on NVIDIA AGX Xavier. This one is a very small form factor, based on NVIDIA TX2 and TX2i. How small this small form factor system is, right? Now let's talk about A178. So A176 is very small, right? But we want to target to wearable device. So, how about this one? This one is truly nano form factor. It's perfect for the wearable device. It's perfect for the UAVs, drones, and many other defense applications. Let's take a close look to the A179 Lightning Nano AI supercomputer. It's based on NVIDIA Xavier NX and Nano, variety of I/O available, Gigabit Ethernet, USB, MIPI, four MIPI CSI video inputs. It's amazing. 1 HDSDI, serial, discrete, CAN bus, USB 3 interfaces. We have M.2 for SSD, NVMe SSD, and removable microSD. Actually, we're also taking PCI Express 4 lanes to the output connectors. This way, we can create a docking station and chain several systems together. This way, we can increase performance each time by factor of 2, 4, 8, and so on. C530. This one is GPGPU 3 VPX AI board. We're creating also an option for SOSA US market. This 3 UVPX board, based on the latest NVIDIA Turing architecture, RTX 3000 and NVIDIA Quadro T1000. 4 video output channels, PCI Express with 16 lanes. This is very powerful board. And 599, based on the latest Radeon E9171 Polaris architecture. This board is perfect for real-time operating systems like VxWorks, Integrity. Windows and Linux, of course, also supported. Up to 4K video outputs. This one is really great board. Starting from 2021, we want to provide software add-ons. We think that the software add-ons can benefit a lot to our customers. Let's take, for example, a health system. These software add-ons can constantly monitoring the health of our boards and systems. AI encode. We can video encode stream from the external cameras, encode in H.264 or H.265 format, and record it locally or remotely. We can also stream this video to the outside board. AI detect. We're providing a software add-on for the customers which using AIs, libraries and code example for the object detection, object classification, tracking, and motion detection for defense market. Dolphin. This is a PCI intelligent network. It provides an API for the PCI Express DMA transfers between the boards. We also entering the FACE, open avionic environment for all military airborne platform types. Thank you for listening. I hope you enjoy my presentation. You can contact me directly to my email address or to sales department.
Hello everybody, I'm Boris Bayer. I'm a VP R&D at Aitech Systems. Today we'll discuss different cybersecurity aspects actual for the new business reality and covering main product development phases. The agenda of this session is based on the understanding on cybersecurity threats, overview of available applicable solutions and explanations of Aitech cybersecurity concept, ASecure. As the density of embedded devices in all parts of modern platforms become higher, it's only natural for the defense and aerospace sector to become more subject to a variety of security threats through all phases of life cycle of embedded system design, starting often with the cyber attacks to gain access to vendors, servers and steal design information, and regularly ending with the successful efforts to take control of the embedded systems or retrieve classified information directly or remotely. So what is the main cyber attack goal? One is stealing data and second one is stealing control. For stealing data we are talking about retrieving security keys, encryption data, intellectual properties of enterprises, intelligence footprints or video. When we are talking about stealing control, take over control of embedded systems, hijack, alter the embedded systems, destroy or stall armored vehicles remotely. When the most of cyber attacks happens, vendors can invest their best efforts in multi-million projects, including the best cybersecurity and anti-tampering technologies to protect the embedded systems from other side adversaries with much limited capabilities and resources may gain access to classified design information. As example, you can see certain resemblance between various elements of the US F-35 and Chinese J-21. During the COVID-19 pandemic crisis, many enterprises are facing reality when, in order to assure continuation of business, remote working become to be major model for operating. Working from home exposes organizations to major cybersecurity risks. Decent security of home-based setups is one of examples. Workstations are often placed in non-secure home Wi-Fi with Xbox, KitchenAids, kits, tablets and mobile phones. The Wi-Fi is protected with very weak passwords. Using multiple endpoints devices, a work mobile computer, home desktop, mobile phone with different installed software level of protection and the vulnerability. Extensive data sharing over
open internet, not encrypted, and sometimes traveling through foreign services. Limited iOS support from home-based devices, not able to perform effective and timely monitoring, controlled backup and update. Private organizations and governmental agencies invest significant efforts in definition of secure cyber environment, improving supply chain immunity against cyber attacks. The US Department of Defense released its Cybersecurity Maturity Model Certification, CMMC framework. CMMC is a set of cybersecurity requirements private contractors must meet in order to be eligible to bid on defense contracts, and their compliance must be audited and certified by an approved third party. It captures best practice, allowing balance between security requirements and effective operating of businesses, including based on remote work needs. In addition to standard access password, the system sends secure code to mobile phone, decreasing probability of access by an unauthorized person. Backup and secure data for recovery in cases of a cyber attack on system failure. Definition of policies, refresh them frequently, periodically train employees to recognize and avoid cyber threats. Different techniques are available to protect embedded systems for cyber attacks. These methods are based on a best practice, common knowledge, and standard commercial tools like authenticated software, protection of network interfaces, non-authorized external media recognition, protecting programmable logic devices from a readback from cloning, prevention of BIOS tampering, prevention of hardware cloning, protection of a software system, protection of a storage by a password, by the encryption, and system tampering recognition and protection. There are many techniques available to protect embedded systems from compromising by adversaries. Those techniques are based on a network, software, and hardware protection. Aitech solution, called Secure Aitech Cybersecurity Open Architecture, is based on the combination of those techniques. The heart of Aitech cybersecurity solution is Smart Fusion ARM operating as a security controller. This controller supervises all security operation of an embedded system. Second component is a trusted platform and boot guard. Xilinx ultra-scale MPSoC FPGA implemented on the Aitech products provides extensive security features. SSD security is another component, and anti-tamper based on a recognition and prevention of physical access to sensitive data. This picture visualizes the main concept of Aitech security. You can see that Aitech security is based on 3 layers. The first layer is a standard security when users implement the commonly used techniques like BIOS write protection, BIOS password, security boot, operating system guard, and different cybersecurity techniques like antiviruses, data encryption, BitLocker, and so on. The second layer is fully based on the standard solid-state disk security. The example for this is write protect, security erase, quick erase, and disk encryption. And on top of 2 layers, we have Aitech unique protection algorithms based on a trusted platform security manager and Xilinx ultra-scale MPSoC device, including a boot guard and tamper protection. The SSD security is based on 3 methods combining the best practices and the algorithms. Those are secure erase, fast erase, and the disk encryption. Security erase and fast erase is based on standard algorithms defined by NSA, DoD, US Army, Navy, and the Air Force. Those algorithms, once applied, continue running until full erase of SSD data. Even if power is interrupted, the process will be started when the power will be applied the next time. Encryption. All our Aitech disks include encryption of data. There are 2 methods of encryption. The first one is transparent for users when the encryption keys are embedded in the SSD, used only when the user wants to erase data quickly in cases of accident, danger of loss data. So this is a very fast method. When this algorithm is applied, encryption key is actually refreshed and all data on the disk become non-readable. The second method comprises of external security key, when operator must enter a security key every time when the power is applied to disk in order to open it and make it available for read and write operations. Xilinx Zinc UltraScale MPSoC is implemented on Aitech main processor boards in order to provide to customer powerful and flexible platform for implementing of their security algorithms. This is a very large and powerful FPGA, providing great infrastructure, fast connection to main processor, and 10 GHz SerDes ports for external connections. This FPGA allows to customers to build their own security controllers. For example, 10 gigabit Ethernet controller or USB controller, fully based on the customer's IPs, full control over the software and the hardware implementation is available for users. The ARM Cortex processor embedded in the main Smart Fusion FPGA has been utilized as intelligence platform management controller and board security manager. The main FPGA was designed to be in the center of the processor architecture, and it's capable of supporting most of the board's vulnerable, more non-volatile resources like BIOS flash, EEPROMs, FPGA configuration files, and SSD. The security manager performs continuous monitoring of integrity of major system elements during all phases of SBC operations. Intercommunicates with the main board CPU to maintain trusted platform and plays key role in applying anti-tamper. Special battery-backed tamper detection mechanism recording unauthorized access to embedded system by opening a system case. Intruders attempt to breach the system is recorded in the volatile memory. After tamper attack, the embedded system is powered again. Security manager will initiate complete system cleanup or just informing operator about this event. Aitech single-board computers provide a comprehensive cybersecurity platform, ASecure, including standard Intel CPU security based on a TXT and the trusted platform, as well as onboard trusted platform module, SSD options with the encryption, quick arrays and security REST features, security manager, tamper detection, and variety of FPGA protection tools. Aitech has also included options for onboard security features and encryption that can be customized in the optional Xilinx UltraScale Plus FPGA. Today's embedded systems face multiple threats through all phases of their life cycle. The security of systems that are used in critical industrial, military, aerospace applications can have real-world implications that can even impact public safety. A comprehensive multi-layer protection strategy should be established from the early planning stages of a project and carefully implemented through the entire project lifecycle.
My name is Alex Trigub and I'm a product line manager for SBCs, switches and IO boards at Aitech. My presentation today will focus on a topic which is extremely important for our industry at this day and age, SWaP-C optimization. In this presentation, I will cover the following. What is SWaP-C optimization and why is it important for the future of the defense industry? What are the main approaches to SWaP-C optimization and how are they implemented in the Aitech product portfolio? How can the basic SBC capabilities be extended through various integrated hardware and software add-ons to create a real multifunctional product rather than just an ordinary single board computer? And finally, I will touch upon some upcoming exciting and innovative products in the Aitech SBC roadmap. Let's start by looking at the future battlefield. How will it change in 5-10 years? The current military market trends clearly indicate a heavy focus on automation. Less human soldiers on the battlefield, more smart equipment, which is either fully automated or remotely controlled. These types of unmanned aerial or ground vehicles can be used both for reconnaissance and combat. Unmanned aerial vehicles or UAVs are already ruling the air. They come in all shapes and sizes, from large combat UAVs like the US Air Force MQ-9 Reaper, responsible for taking down terrorists in distant areas, or tiny drones that can be launched by soldiers in the field or even in urban combat zones to scout for exact enemy locations. Closely following the UAVs developments are UGVs, or unmanned ground vehicles. This can be used for ground strikes or for transport of heavy equipment through dangerous war zones. In some cases, a UGV may even carry a small aerial drone and launch it on demand in a remote area. Removing the need to host a human pilot or driver not only saves lives, but also allows to greatly shrink the size and weight of these unmanned vehicles, which in turn improves their abilities in the field and reduces costs. Such unmanned vehicles require sophisticated high-resolution cameras, radars, and other sensors, as well as high-performance computing capabilities combined with artificial intelligence to process data from all the sources in real time in order to react quickly to various external conditions and threats. And all of this must be implemented in a relatively small and lightweight package. So other pillars of the future battlefield are smart soldiers and military robots. For human soldiers, special wearable equipment will provide augmented reality capabilities to be able, for example, to quickly distinguish friend from foe, and smart sensors that are able to detect an ambush or improve the soldier's aim in situations with limited visibility. It will also help the remote command center to keep better check on all soldier locations and threats in real time, and improve their tactics as battle progresses. Future military robots may serve as soldier companions to carry heavy equipment or clear the way in hard-to-pass areas. Obviously, implementing smart soldier equipment and field robots will require even further shrink in weight and size of the processing hardware, while still requiring advanced computing capabilities. Finally, all these various automated players on the future battlefield must be coordinated through effective communications and automated coordination protocols. So, for example, a drone picking up an enemy activity in a hidden spot will automatically warn the nearby squad of possible ambush. In a joint land-aerial strike, the command center can quickly select the most effective way to attack each target in real time, be it an unmanned tank, a UAV, or a nearby human soldier. Such automated coordination system from Rafael in Israel, called Fireviewer, is already able to shorten the time required to complete an attack and destroy the target by 3 times. So what is SWaP-C and how is it related to the future battlefield? SWaP-C is not a new term. It's getting increasingly important as the size of military equipment keeps shrinking. As I mentioned on the previous slide, unmanned vehicles, military robots, and smart soldier equipment are all becoming increasingly limited in size and weight. So SWaP-C stands for size, weight, power, and cost, and is usually mentioned in the context of optimization of all these parameters or some of them. Size is the most straightforward one. Obviously, if you're building a small aerial drone, you cannot afford to use a racked computer from a traditional military aircraft like F-16, as that computer itself may be the size of the whole drone. Weight is also very important, especially for UAVs, but also for ground vehicles in order to increase speed and agility or maneuverability. Of course, limiting the size of a racked computer will usually also lower its weight, but this also may depend on the specific materials used. Power consumption is another important factor, which affects all others as well. Lowering the power consumption of computing and processing elements of a system helps reduce the size and weight of power supplies and cooling elements, which in turn also reduce both the equipment costs and the energy costs. And the defense market is becoming increasingly cost-aware. In this new reality of COVID-19, defense budgets are more limited than in the past, while the military is required to do more and more with less money and resources. Also, while the field equipment and unmanned vehicles are becoming smaller, their numbers are growing accordingly, which means the total cost of ownership of each individual piece of equipment, which is, for example, a small drone, must be much less than of a large drone or unmanned aircraft. All these parameters, size, weight, power, and cost, affect each other and must be carefully taken into consideration all together and each one individually when designing products for this new era of automated and highly effective defense systems. So while thinking about SWaP-C optimization, people usually envision small form factor systems or shrinking of existing equipment to smaller size and weight or smaller overall SWaP-C. This is what I call the same for less approach. This approach works well for small drones and wearable soldier equipment, as there is no other choice there. In other cases, however, in large drones or airborne targeting pods, such as the one shown on bottom left, there may be more room even to host a full 3UVPX system. In that case, however, the approach may be to integrate much more value-added functionality into the same size system, without increasing the overall swap-C. This is what I call the more for same approach. The trade-off between having much more functionality and performance in the same form factor or having the same or sometimes more as the technology progresses functionality and performance in a much smaller form factor will always depend on the target application. In any case, both approaches are valid and required to build a full product portfolio with swap-C in mind. And that is why at Aitech we have a wide product portfolio covering both of these scenarios and are constantly improving and advancing our products in both of these categories. This slide shows some examples of exciting Aitech products adhering to both swap-C optimization approaches. On the left you can see 3UVPX boards and systems under the more for same approach. These boards and systems pack a lot of value-added functionality, performance and security enhancements through various hardware and software add-ons. I will touch upon this in more detail in the following slides. The 3UVPX systems such as the A19X series are extremely flexible, modular and customizable. They may host a variety of functions within the same enclosure, for example, one or more high-end SBCs, advanced DPGPU boards, switch and I/O extension boards, all packed into the same 3UVPX chassis. On the right, under the same for less umbrella, you can see various small form factor systems. They have specific, fixed, dedicated functions such as small rugged Intel architecture computer, a standalone internet switch or router, and a remote I/O extension unit. We are already working on significant improvements in both of these portfolio sectors. On one hand, to pack even more functionality and performance into the 3UVPX boards and systems, while on the other hand, to further reduce swap-C of the small form factor systems. And at the same time, make them more flexible and extensible. If you're interested in more information or details on any of these products, you're welcome to visit our website after this presentation or contact Aitech Sales. Here I would like to talk about my long-term vision for the two sides of the swap-C coin, focusing on single-board computers and standalone ranked computers. On the slide, you can see a comparison between the different aspects and parameters of each type of products. And as you can see, there are some similarities, but also major differences between the two. For example, on the right side, we are looking at much more power-efficient CPUs with up to 4 cores today, possibly growing to 8 cores in the future, while on the left side, for most performance-demanding applications, it's possible to grow up to 16 cores with high-end embedded processors like Intel Xeon D, and in the future, possibly even 32 cores using power-efficient ARM architecture. We are definitely looking into both Intel and ARM in the long term, although our focus in the 2021 roadmap is the next generation of Intel processors. So for more for same approach, we are talking mainly about 3UVPX boards and systems. High-end processors and various add-on hardware and software functions embedded into the same 3UVPX board, as we will see on the next slide. In case you haven't heard yet, Aitech is now a member of both SOSA and FACE consortiums, as we are committed to full alignment with these industry standards for bringing more innovation and interoperability into the market and to our customers. This slide shows the concept of Aitech flagship 3UVPX SBCs, or what I like to call more than a computer. This means that our specialty as part of the more for same approach is to pack much more functionality and performance than just an Intel processor into the same relatively small 3UVPX form factor. Besides having a high-end embedded Intel CPU with up to 16 cores, these SBCs provide large RAM and storage capacity. One of the main attractions is the large onboard Xilinx FPGA, which allows the offloading of heavy processing function from the CPU, or enhancing the system security. Having this FPGA on board means there is no need to buy an additional FPGA board, which in turn reduces both size, weight, and cost of the system. We'll touch more on the onboard FPGA possibilities in a minute. Speaking about security, Aitech flagship SBCs feature an advanced iSecure cybersecurity framework, which was covered in the previous presentation by our VP of R&D, Boris Bayer. High-speed connectivity, currently supporting up to 8x or 16x PCI Express Gen 3, depending on specific SBC, and up to 40 gigabit Ethernet, allows fast connection to GPGPUs, high-resolution GigE vision cameras, and other high-bandwidth sensor I/O. If the onboard functionality is not enough, XMC and M2 sites, depending on the specific SBC, allow adding functionality within the same 3UVPX form factor without using an additional slot. Aitech offers a variety of innovative XMC products, such as a fully managed Ethernet switch router on XMC, so it's possible to build a subsystem, what I call smart sandwich, of SBC, Ethernet and Ethernet switch using only a single 3UVPX slot. M2 slots allow adding secure storage as well as special I/O like CAN bus, or in the future FPGAs and dedicated AI acceleration based on the Intel Movidius visual processing units, all in a very space-efficient form factors. With support for various software add-ons like A-Health, Health Monitoring, and Dolphin PCI Express connectivity framework, our customers can really do a lot with this relatively small 3UVPX board. By the way, we just announced our newest member of the SBC family, the UC8770 SOSA line Intel SBC. This SBC features the Intel Xeon D CPU with up to 16 cores and is fully aligned to the SOSA 3U IO-intensive SBC profile, supporting both PCI Express and 40 gigabit Ethernet data plane options. It is designed specifically with US customers in mind, and if required by the customer, can be manufactured in the United States. So on the following slides, we will look a bit deeper into some of the aspects of the more than a computer approach. First, let's discuss the value of having a large onboard FPGA. FPGAs can be used to offload heavy workloads from the CPU, for example, data encryption or signal processing tasks. Having such FPGA on board saves system footprint and power budget, as well as costs. FPGAs are going through an immense evolution process during the last several years. Besides the ever-increasing logic and memory densities, they provide internal CPU ARM cores, making a true system on a chip. These internal CPU cores allow also offloading of FPGA control functions from the main CPU. Specialized integrated hardware functions like analog RF I/O and processing are now also part of the innovative FPGA SoCs within the Xilinx RF SoC product line. And these functions are fundamental for some military applications like radars. Xilinx next generation FPGAs, which they now call ACAP, Adaptive Compute Acceleration Platforms, will also include specialized and highly parallel artificial intelligence acceleration and DSP engines, in addition to the ARM Cortex-A72 CPU cores and traditional programmable logic. All in all, having an advanced FPGA SoC on board and SBC significantly increase the capabilities, capacity, and performance without increasing the overall footprint. However, integrating such FPGA onto a 3UVPX board is not an easy feat, and it greatly complicates board design and layout. Aitech has proven this capability with our existing C877 and C878 products, which include an onboard Xilinx Zinc UltraScale MP SoC without compromising the other high-end features of the SBC. As I already mentioned, our next generation flagship SBCs will also feature even more sophisticated onboard FPGAs, such as RF SoC or the next generation adaptive compute acceleration platforms. Let's talk about iSecure. Thanks, Boris, for the detailed presentation explaining all aspects of our advanced cybersecurity framework. I'd like to take it a bit higher and talk about the main value to our customers. What iSecure really provides is increased survivability and level of confidence in the field, with much lower chances of a cyber attack during an actual deployment or maintenance of the system where the Aitech SBC has been installed. With the defense market adopting more and more advanced technologies from the civil market, these technologies also bring with them more potential cybersecurity issues and holes. So having a secure solution on the battlefield is becoming increasingly important. Not only to protect human lives during an actual battle, but also to protect sensitive or confidential data from being compromised, stolen, or modified for malicious purposes. That's why iSecure protects the SBC itself in terms of hardware, firmware, software, as well as data being stored on it on multiple levels. In addition, some of the aspects of iSecure provide protection from reverse engineering and cloning of firmware and software, which makes the system safer for export to allies. Some words on software. Our goal at Aitech is to increasingly provide more and better value to our customers. And part of this will be done by putting more focus on an investment in software add-ons and solutions going forward. Here are some examples of add-ons software modules we are planning to develop during 2021. iHealth is Aitech integrated health monitoring solution, which provides a common health monitoring API across our platforms and allows collecting health status from various hardware components, predicting failures, and performing online system performance monitoring. We are going to integrate the PCI Express Fabric Communication Library from Dolphin Integrated Solutions. This library supports high-speed, low-latency peer-to-peer communication between PCI Express devices. It simplifies customer application development and shortens time to market by hiding the complexities and technical details of programming PCI Express devices directly. And finally, as part of our commitment to new interoperable standards, we are going to provide operating system and board support packages options with phase conformance based on WindRiver Linux and VxWorks 653. Here are some examples of how SBC functionality can be further extended through XMC mezzanines. XMC provides a way to add significant capabilities within the footprint of a single 3VPX slot. Some of our most innovative XMC products are managed and managed Ethernet switches like the M620 and the M640, which support Ethernet speeds up to 1 gigabit Ethernet and up to 16 ports on the M620, the fully managed Ethernet switch router on XMC. This creates a very efficient combination of XMC and switch in a single 3VPX slot. The next generation of Ethernet switching technology will support 10 GigE and 40 GigE interfaces and advancing further to 100 GigE based on 25 Gbps SerDes lanes with fully featured layer 2 and layer 3 networking capabilities and very fast boot times. In addition, we are working on new graphics and IO extension XMCs as shown on this slide. Now, let's explore the other side of the SWaP-C coin, the same for less approach. Here, as you can see, the main focus is on minimizing the form factor and power consumption and not on performance or integration of multiple functions, although some minimal degree of performance and capacity is still required. And CPU vendors like Intel are able to significantly increase computing performance and add more functionality within the same power envelope, as you will see on the next slide. Some of the products in this category, especially those based on PowerPC architecture, are also DO254 and DO178 certifiable for flight safety critical applications. One of the newest exciting products, which is very relevant to SWaP-C optimization, is the Intel Tiger Lake UP3 system on chip. This system on chip provides a powerful CPU and a powerful integrated GPU alongside inherent artificial intelligence acceleration instructions, powerful video processing, and security enhancements. All this while keeping the overall power consumption at low-medium level of either 15 watts or 28 watts, depending on the CPU frequency. And the CPU is based on Intel 11th generation core with up to 4 cores and 8 threads, and around 20% increase in single-thread performance versus the previous generation. On top of the pure CPU performance, further improvements are gained through the increased memory bandwidth. The GPU is the Intel 12th generation GPU technology with 96 execution units. According to initial benchmark, this GPU is powerful enough to deliver similar performance to some NVIDIA discrete GPUs, so for some applications, this integrated GPU can replace the external GPU, saving both space, power, and cost. This CPU also provides new cybersecurity capabilities for better protection of keys and memory contents, as well as protection against flow control-based attacks. These new capabilities will be fully integrated into the iSecure framework. And due to its small size and limited power envelope, while still providing an excellent performance balance between the Scalar, that is CPU, and the Parallel, that is GPU processing capabilities, this system on chip is perfect for next generation of SWaP-C optimized solutions. So Aitech is now working on 2 exciting next generation products based on the Intel Tiger Lake UP3 CPU SoC, a 3VPX SBC, and the modular rugged mini computer. UC8500 is a SOSA-aligned 3VPX SBC providing an excellent balance of CPU and GPU performance versus power and costs. It features 32 GB of RAM and up to 2 TB of M2 storage. It also features additional M2 and XMC sites for further extensions, as well as our advanced cybersecurity framework, which we already covered. It will also feature phase-conformant OS and BSP. The A181 is an innovative small form factor concept for small unmanned vehicles and robotics that we are designing around the Intel Tiger Lake UP3 SoC. It's a modular rugged mini computer. It will be available as a standalone miniature base unit featuring a fully functional computer with Intel architecture CPU, integrated GPU, and artificial intelligence acceleration capabilities. This provides a balanced combination of both the powerful CPU and the GPU with basic I/O like Ethernet and USB. However, in addition to the base unit, various extension modules will be available, providing either I/O extensions for avionics, such as 1553B or RINC428, additional AI acceleration where higher GPU performance is required, or FPGA, which can be used for example offloading of digital processing function or additional security enhancements. Finally, a couple of words about our small form factor switches. This includes the currently available A664, which supports up to 16 1 gigabit Ethernet ports, with 4 of them being fiber optical ports. And fiber optics enable applications where copper cable link distance, bandwidth, or physical characteristics are unacceptable. And the A664 is a fully managed switch router supporting a variety of layer 2 and layer 3 networking capabilities alongside security enhancements and fast boot mode. It's SWaP-C optimized, weighing less than 2.5 kilograms, with power consumption limited to 25 watts. And the next generation switch in this series, the A665, is currently under development and will feature 10 gigabit Ethernet, 40 gigabit Ethernet, and even one or more 100 gigabit Ethernet optical interfaces within a much smaller enclosure. Thank you for watching. I hope you enjoyed this presentation. We covered a lot of material, and my intention was to provide an overview of concepts and technologies, as well as existing and future Aitech products aimed at solving the SWaP-C optimization challenges of the future battlefield. If you have any questions on this or other related topics, or would like to get more information and details about the products I presented, feel free to contact us through the website or the sales channels, or email me directly at the address shown on the slide. Have a good day, stay safe and healthy.
So now we're going to go into our Q&A session with our experts to make sure that we're answering any questions you have on the material that was covered today or anything else that you wanted to ask about.
I would like to welcome my colleagues here live in our virtual studio to the experts panel Q&A. Dan Moore, Boris Bayer, and Alex Trigub. How can we implement our own cybersecurity features using Aitech hardware?
Actually, the AI secure concept is open frame, designed to allow to customers very flexible implementation of their concepts, their algorithms, security algorithms, or encryption keys and storing of encryption keys and algorithms, and the implementation their own concept and their own way to protect the systems. So we provide all the tools, all low-level tools, kind of infrastructure to implement and to customize any cyber protection scenario, from recognition up to performing actions in order to alarm or clean up all the system. For example, we have an anti-tamper mechanism recognizing any intruder action, like opening of a system case, and then the user can define the way how he prefer to act, either to just to alarm or prevent for system to work, or to perform full cleanup of all non-volatile devices. Another mean is a very sophisticated FPGA provided by Xilinx. So this FPGA, it's Zinc Ultra Scale MP SOP, residing on the board, and it's under full control of a customer, of user, and user can implement any security algorithms there. To implement their codes, the ways they manage encryption keys, and build their own concept based on Aitech infrastructure called Secure.
Thank you, Boris. I have another question from the audience for Dan. Can we dump image from NVIDIA Jetson-based system and clone it on other production units?
Thank you for the interesting question. Actually, all Jetson-based system has special recovery mode. Once you're entering recovery mode, you can dump an image, clone image, and further burn it on all production systems. All the procedure actually described in our user manual, so all the documentation customer can get from us. So very easy procedure, and we familiar with it.
Okay. We have another question for you. Okay. Can we upgrade by ourselves to a more up-to-date Jetpack on NVIDIA Jetson-based system?
Yes, we constantly upgrading Jetpack for the latest available from NVIDIA. We also have entire source code of the bootloader, device tree blob, and the kernel. We can either provide the entire image to our customer, or we can help to our customer and provide the source code, so the customer will be able to compile device tree blob or kernel or build his own root file system.
Thank you, Dan. Apparently, we have another question for you. What if we had to add different capability which does not exist on COTS products?
Most of the time, we're selling slightly modified systems since every customer required special features. So the system built in very flexible way. We have expansion ports like M.2 expansion port, mini PCI port. So we're talking to our customer and getting new requirement. Usually we're able to buy COTS expansions like additional I/O boards, frame grabbers. Then we need to usually port some Intel-based driver to the ARM architecture. We have all the capabilities in-house, and then we can provide additional features to our customers.
Thank you. Alex, we have a question for you. Can you elaborate about operating systems and BSP support for your Intel SBCs?
Thank you, Shani. And so for our Intel SBCs, we provide a large variety of board support packages for different operating systems covering various scenarios and target use cases. So we support Linux, Windows, and VxWorks. For Linux, we provide a generic board support package with source code for all drivers so the customer can compile it with their own Linux distribution. And in some cases, we can also provide pre-integration services for additional NRE, or we can provide a Linux integration support package with support hours to help the customer integrate the BSP with their specific distribution. In some cases, we also have pre-integrated BSP for Ubuntu Linux and Red Hat Enterprise Linux. And for Windows, we support Windows up to version 10, and VxWorks up to version 7. And also, as part of our commitment to go with new industry standards like the DoD FACE standard in the US, we are going to support FACE conformant operating systems and boards support packages in 2021.
Thank you, Alex. Thank you, guys.
Now that we have completed the very first Aitech Virtual Customer Forum, we are looking to get your customer feedback on how we can best improve our products with the customer survey. If you do fill that out after the session, please feel free to either follow up with any questions you may have for our experts, as well as any other questions you're looking to pose to our Aitech team. Don't forget to fill out that customer satisfaction survey and enter to win the $100 Amazon gift card that we'll be notifying after the events.